Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. This is video number 8, whereby I'm focusing on rates of reactions. Please do expect a total number of 11 videos, which simply means I will be answering 11 different questions, and all of these questions are extracted from past exam question papers. And it's very important for you to know how to tackle such questions because it will give you an edge whenever you write your exam. So please guys, do share the video to your peers so that they may have the same edge as you do. Okay, we are told that the reaction between dilute hydrochloric acid and sodium thiosulfate is used to investigate one of the factors that influence reaction rate. The balance equation for the reaction is given below. We have our sodium thiosulfate and hydrochloric acid as our reactants, and then they will give us the products, and the products are sodium chloride, sulfur, water, as well as sulfur dioxide. Excuse me. The hydrochloric acid solution is added to the sodium thiosulfate solution in a flask. The flask is placed over a cross drawn on a sheet the flask is placed over a cross drawn on a sheet of white paper, as shown in the diagram below. The time that it takes for the cross to become invisible is measured to determine the rate of reaction. Okay. And then we are told that 4 experiments A to D are conducted during this investigation. The volume of reactants used in each of the four experiments and the time of the reactions are summarized in the table below. Okay. Okay, we are given the volumes of sodium thiosulfates in all four different experiments are together. The volume of our hydrochloric acid is the same. However, the volume of the volume of sodium thiosulfate is the one that is not the same altogether. So this simply means that they're trying to tamper with the concentration of our sodium thiosulfate, because we can see over here. We have 25 cubic centimeters of just sodium thiosulfate altogether. Over here we only have 20 cubic centimeters of pure sodium thiosulfate, and then they've diluted it with 5 cubic centimeters of water altogether. We had 15 over there, and then they've diluted the sodium thiosulfate with 10 cubic centimeters of water. Over there we have 10 and then 15 cubic centimeters of water. So what they are basically doing over there, guys, is to just dilute our sodium thiosulfate together. And obviously if ever we dilute our sodium thiosulfate, this will tamper with the concentration of the sodium thiosulfate. Okay, and then now they want us to state 2 factors that can influence the rate of reaction. We have concentration as number 1, concentration, as well as pressure. Are you together? In this reaction, guys, only 4 factors will work. No? The pressure, concentration, excuse me, temperature, as well as the addition of a catalyst. Those 4 factors will work, but the one of increasing the surface area or changing the state of division will not work. Why? Because both of our reactants are in aqueous solution. Are you together? If we had either one of the reactants as a solid, then we were going to tamper with the state of division. Né? But now the only factors that might change the reaction, just the change in concentration of our reactants, an increase in pressure, temperature, as well as an addition of a catalyst. So any 2 of these 4 will change. Will have an impact in our reaction rates. Nah? Okay, And then now we must write down the name or formula of the product that causes the cross to become invisible. Over here, we can see that this thing over there, that sulfur dioxide gas, there's no cotton wool there at the top just to prevent it from escaping the vessel. So the sulfur dioxide gas will simply escape the reaction vessel, and then we will be left with water, which is a liquid, and then the sodium chloride, which is colorless. So the only element that will make us not to see the cross will be sulfur. Are you together? Because sulfur solid will form there, and such that this will end up not seeing the cross over there. Are you together? So sulfur is the one that sulfur is the product that will help us not to see the cross. Okay, give a reason why water is added to the reaction mixture in experiment B to D. Water was, as I just said, guys, water was added just to dilute the solution of sodium thiosulfate. And obviously, if you dilute a solution, you are simply decreasing its concentration. Are you together? And remember that, guys, if you decrease the factors that influence the reaction rate, obviously the reaction rate will also decrease, which simply means that our chemical reactions will take more time to reach completion. We can see that from reaction B to reaction D, the reaction takes more time to reach completion as compared to the first reaction. Are you together? So the reason of changing of adding water into the mixture was to just dilute the solution of sodium thiosulfate, and hence and the dilution of sodium thiosulfate will obviously tamper with its concentration. Are you together? So the reason is just to dilute sodium thiosulfate. Then I must write down an investigative question for this reaction. We can simply say, how does the concentration, or rather, how does the change in concentration of sodium thiosulfate affect the rate of reaction? Are you together? How does the change in concentration of sodium thiosulfate affect the rate of reaction? And then now we must simply use the collision theory to explain the difference in reaction rate between B and D. Between B and D, we can all see that, guys, for experiment B, the dilution of the solution was a bit smaller, but at D, the dilution of our solution was a bit higher because they've used more water. Are you together? So if I compare experiments B and D, I'll simply say experiment B will have a higher concentration. Are you together? And then since experiment B will have a higher concentration, it simply means that there will be more particles present in experiment B. And since I have more particles, that means I'll have more effective collisions, and hence there will be a greater reaction rate. Okay, excuse me. And then the original sodium thiosulfate solution was prepared by dissolving 62.5 grams of sodium thiosulfate crystals in distilled water in a 250 cubic centimeter volumetric flask. They want us to calculate the mass of sulfur that will be formed in experiment D if our sodium thiosulfate is a limiting reagent. A limiting reagent is a reagent that will be used up completely in a chemical reaction. Are you together? Okay, so now let's find out the number of moles of or rather the concentration of our sodium thiosulfate. The initial concentration of our sodium thiosulfate will simply be excuse me, mass divided by molar mass times volume. The mass is just 62.50, and then molar mass for sodium thiosulfate, let me write it somewhere there. Molar mass for sodium thiosulfate, sodium is just 23. Since I have two of them, I'll say multiplied by 2, plus sulfur is 32 multiplied by 2, oxygen is 16 multiplied by 3. So this will simply give me 23 times 2 plus 32 times 2 plus 16 times 3. This will simply give me 158 grams per mole. So that's my relative atomic mass number, né? And please note that, guys, I got these 23, 32 and 16 on my periodic table, né? Okay, so the molar mass is simply 158, and then my volume, remember that, guys, whenever I'm using this equation, the volume should always be in cubic decimeters. So I'll simply say 250 divided by 1000. I'll simply get 0.25. For me to change from cubic centimeters to cubic decimeters, I must always divide by 1000. So, and then my final answer will simply be 62.50 divided by 158 multiplied by 0.25. So this will basically give me 1.58 more, but I don't like rounding off before the final answer. Let me write the full answer as it is, né? It's 1.582278.481 mole per cubic decimeter. So this is the concentration of our sodium thiosulfate altogether. So since they want us to find the mass of the sulfur which was formed in experiment D, if my sodium thiosulfate was a limiting reagent, okay? This simply means I'm just supposed to calculate the number of moles of my sodium thiosulfate in experiment D. How can I do that? I know that the number of moles of my sodium thiosulfate is simply equals to the concentration multiplied by volume. Yeah? Remember that, guys, the equation is given to you. Let me check how is it given to you. Yeah, it's given to you as C is equals to N over V. Are you together? For me to find N, which represents number of moles, I just had to cross multiply, and therefore I had number of moles is equals to concentration multiplied by volume. So the concentration is basically 1.582278.481, and then my volume for experiment D, they only use 10 cubic centimeters. Are you together? So this will simply be 0.01 moles per cubic decimeter. Remember that, guys, for me to change from cubic centimeters to cubic decimeters, I just had to say 10 divided by 1000. I'll simply get 1 over 100, which is just 0.01. And then this will give me the number of moles of my sodium thiosulfate present in experiment D. So I'll take my concentration, multiply it by 0.01, and this will give me the number of moles to be equal to 0.01582278481 moles. So this represents the number of moles which are present in experiment D, for sodium thiosulfate. But remember that, guys, according to ratio and proportion, the stoichiometric coefficients there for both sulfur and sodium thiosulfate, I have 1:1. So it simply means that for me to form this amount of sulfur, rather for me to form a certain amount of sulfur, I need to use the same amount of sodium thiosulfate, because the ratio is just 1:1. So the number of moles for sulfur, I'll simply have 0.01582278481 moles together. So for me to find the mass, I'll simply say number of moles is equals to mass divided by the relative atomic mass number. So therefore, number of moles is basically mass, or rather, therefore the mass of my sulfur is basically number of moles multiplied by the relative atomic mass number. That's 0.01582278481 multiplied by the relative atomic mass number. Sulfur is equal to 32 grams per mole. So this multiplied by 32, I'll simply get a mass of 0.506, and then now I can simply round off to 2 decimal places. Now this will be 0.51 grams. So mass for sulfur in experiment D will simply be 0.51 grams. Let's go back. Firstly, I calculated the initial concentration of my sodium thiosulfate. Are you together? Remember that I was given 62.5 grams, as well as the 250 cubic centimeters. Are you together? And then I calculated the concentration of my sulfur. After finding the concentration, I then went to calculate the number of moles that were used in reaction D. Are you together? And I did that. I used the same concentration I found there to find the number of moles. And the volume in reaction D was simply 10 cubic centimeters, which I converted to cubic decimeters. Are you together? Then I found the number of moles of my sodium thiosulfate, and then since the ratio is just 1:1, that means the number of moles of sulfur that will be produced will be the same as the number of moles of sodium thiosulfate that will be used. Excuse me. After finding the number of moles for sulfur, I can simply go and calculate the mass, and then I simply got 0.51 grams. I hope, guys, the video helped you out. Just stay tuned and wait for more videos. Thank you.